We will wrap up the second section of Unit 1 with Section 1.2.4, Applications of Inequalities. Now, in math class, you've probably figured out that application is code word for word problems, right? So we're going to do a couple of examples where we use inequalities to solve a real-life situation. Now, before we begin example 3, I just want to ask you a question. Have you ever gotten onto a really crowded elevator and felt a little bit nervous? When people are all packed in there, maybe you're in the business building of AC and you're riding to the 4th floor and everybody has their backpacks and it's a very full elevator and you wonder, can the elevator safely lift this many people to the 4th floor? Well, like we're going to see here in our next example, you could use an inequality to solve that problem. In example 3, we're not looking at an elevator, but we're going to be considering a bucket truck lifting bundles of shingles onto a roof. So here's the problem. A roofing company uses a bucket truck to lift bundles of shingles onto a roof. Each bundle of shingles weighs 67 pounds. The platform capacity of the bucket truck is 500 pounds. How many bundles of shingles can be safely lifted in one trip if the operator weighs 165 pounds? Write your answer using a complete sentence. Now, I highlighted those important numbers. They're going to be involved in our model of this problem. So the idea is you've got this bucket truck lifting shingles, you've got this operator riding that bucket truck with the shingles up and down to complete the job. Our question says, how many bundles of shingles can be safely lifted in one trip? So we know that the capacity of the bucket truck is 500 pounds. So we want to make sure that every trip has less than 500 pounds, exactly 500 pounds or less than 500 pounds each. So let's suppose that X represents the number of bundles of shingles. That's the question that we're trying to answer. How many bundles? So X will be our number of bundles. Now, let's consider one trip. We know the operator weighs 165 pounds, and we don't know how many bundles he's going to be lifting, but we know that each one weighs 67 pounds. So if it's 67 pounds per bundle times the number of bundles, then 67x would give us the total weight of the bundles of shingles. Now, we don't want this to exceed the capacity of the truck. So we're going to set that less than or equal to 500. This is our model of the problem. That's what's called a mathematical model. That's the hard part. The easy part is solving the inequality. To solve the inequality, we're going to subtract 165 from both sides. This is going to give us 67x on the left side. Just going to pull up my calculator here. 500 minus 165. That gives us 335 left over on the right side. Then we will divide both sides by the variable's coefficient, 67, and we will have successfully isolated x. Let's divide 335 by 67. Comes out perfectly to 5. So x, the number of bundles, has to be less than or equal to 5. So let's respond to the question using a complete sentence. We can say the operator can safely lift 5 bundles. Now, that's the exact solution, but we have to indicate that we were solving an inequality with our words. So we would say 5 bundles or less in each trip. Notice that was a simple inequality because it had one inequality sign. Think about that next time you're on an elevator. Let's try example 4. Maybe you've found yourself in this situation before. It's the end of the semester, you're facing final exams, and you want to know, what do I have to make on that final to pass the class? Or what do I have to make on that final exam to get an A in the class? Let's solve an inequality to answer a similar question. To earn an A in a course, you must have a final average of at least a 90. Notice the words there indicate we're dealing with an inequality. On the first 4 exams, you have grades of 86, 78, 94, and 88. If the final counts as 2 grades, here's the question. What must you get on the final to earn an A in the course? What must you get on the final to earn an A in the course? So our unknown here is our grade on the final. So let's call that X. Let X equal our grade on the final exam. Now, you have a lot of experience with this in all your years of schooling, that when you find your average grade, you add up all your grades and divide by how many grades you have. That's what we're going to do here. The only problem is we have one unknown grade and we know that it's going to count twice. So let's make sure and reflect that in our model. So we'll begin by adding up the grades that we know. 86 plus 78 plus 94 plus 88. Those are the grades that we know, but the final's going to count twice. So we're going to add X twice. Then we're going to divide by the total number of grades that we have there. Now, it's not 5 grades because the final counts twice. That's a total of 6 grades. Now, our goal is to make an A, so we want this average, what we have expressed here is the average. We want it to be at least a 90, so greater than or equal to 90. That is our model. All we have to do now is solve the equation or solve the inequality. So I'm going to begin by adding up those 4 grades. I'm just going to use my calculator to do that. 86 plus 78 plus 94 plus 88 gives us 346. So we have 346. We'll go ahead and combine like terms here and call that 2x divided by 6 is greater than or equal to 90. Now, let's cancel the 6 by multiplying both sides by 6. I'm going to multiply this side by 6 over 1 and multiply this side by 6. On the left, that denominator cancels, and we have 346 plus 2x is greater than or equal to 540. Notice it gets easier with every step. We're going to subtract 346 from both sides because our goal is to get x by itself on the left. So let's evaluate 540 minus 346, and we end up with 194. We have 2x greater than or equal to 194. Then we'll finish by dividing both sides by 2. And that would give us x is greater than, I think, let me double check, 97. Woo! You have to make a 97 or higher on the final to make an A in the course. That's a little bit of pressure, isn't it? So let's respond in a complete sentence. To earn an A in the course, you need to make a 97 or higher. This language indicates that I was solving an inequality, not an equation. You need to make a 97 or higher on the final exam. You know what that means? Start studying. All right, this completes section 1.2.